Hello everyone. Today we'll study quadratic function. The general form of a quadratic function looks like this. f of x equal to as squared plus bx plus c. That's the general form of a quadratic function. Note, the graph of a quadratic function is always a parabola. It looks like this. Either it's open upward or it's open downward. That's the graph of a quadratic function. In general, if a is greater than 0, the parabola is open upward. If a is less than 0, if a is negative, the parabola is open downward. That's the graph of a quadratic function. Another way to write a quadratic function is the standard form. The standard form of a quadratic function looks like this. f of x equal to a times x minus h squared plus k. That's called a standard form of a quadratic function. In a standard form, if a is greater than 0, the parabola is open upward. If a is less than 0, the parabola is open downward. And the point h comma k is the vertex of the parabola. So, if a is greater than 0, the parabola is open upward. If a is less than 0, the parabola is open downward. And the point h comma k is the vertex of the parabola. The point h comma k is the vertex of the parabola. Vertex means the turning point. The point h comma k is a vertex. Vertex means the turning point. So the standard form is also called the vertex form. The standard form sometimes is also called the vertex form. Because in the standard form, the point h comma k is the vertex of the parabola. Next, if we look at the graph of the parabola, we can see that the parabola is always symmetrical. The parabola is always symmetrical. This line is called the axis of symmetry. This line is always called the axis of symmetry. The parabola is always symmetrical. This line is called the axis of symmetry. The axis of symmetry is always a vertical line. Vertical line is always in the form of s equal to some number. And here we can see that here. Axis of symmetry always goes through the vertex. Axis of symmetry always goes through the vertex. So its s coordinate must be the same as the vertex. Since axis of symmetry always goes through the vertex, so its s coordinate must be the same as the vertex. So this line is always s equal to h. The axis of symmetry is always the line s equal to h. So this line is always s equal to h. This line is always s equal to h. On this line, its s coordinate is always the same as the vertex. because the vertex always located in the axis of symmetric. Next, let's look at some examples. Find the following quadratic functions with the given vertex and a point on the parabola. First example, the vertex of the parabola is the point 1, 3, and a point on the parabola is the point 2, 5. We try to find the quadratic function. Here we try to find the quadratic function using the standard form. In the standard form, h and k represent the vertex. So first step, we plug in h and k, plug in the vertex for h and k. So if I plug in h and k, I get a times x minus 1 squared plus k. K is 3. First step, plug in the vertex for h and k. Next, we try to find a. Try to find a using the given point here, using another point here. Try to find a. So for this point here, 2 represent x, 4 represent y. For this point here, 2 represent x, 4 represent y. We plug in 5 for y. Here, y represents f of x. So plug in 5 for y. Here, y is f of x. We don't know a. We are looking for a. X is 2. Then solve an equation for a. Solve an equation for a. 2 minus 1 is 1. 1 squared is 1. A times 1 is a. Next, I can subtract 3 from both sides. So I get a equal to 2. So for the final answer, plug in 2 for a. F of x is 2 times s minus 1 squared plus 3. Next, we can multiply. Expand the perfect square first. S minus 1 squared is s minus 1 times s minus 1. If we distribute, we get s squared minus x plus 1, which is s squared minus 2x plus 1. So 2 times s squared minus 2x plus 1 plus 3. Then distribute 2. We get 2x squared minus 4x plus 2 plus 3. So we get 2x squared, combine like terms, 2x squared minus 4x plus 5. That's f of x. In general, we know the final answer in the form of ax squared plus bx plus c. So that's the final answer. Next example. Assume the vertex of the parabola is 2, 1. And the point on the parabola is 4, 11. 4, negative 11. Find the quadratic function. First step, we plug in the vertex for h and k. First step, plug in the vertex for h and k. So f of x equal to a times s minus 2 squared plus 1. First step, plug in the vertex for h and k. Next, use the given point here to find a. So from the given point here, 4 represents x, negative 1 represents y. Y is f of x. So I plug in negative 11 for f of x. We are solving for a, so we don't know what a is. X is 4. Then solve the equation for a. 4 minus 2 is 2. 2 squared is 4. Plus 1. So we get negative 11 equal to 4a plus 1. Next, I can subtract 1 from both sides. If I subtract 1 from both sides, I get negative 12 equal to 4a. Then I can divide both sides by 4. If I divide both sides by 4, I get a equal to negative 3. So for the final answer, plug in negative 3 for a. We get negative 3 times s minus 2 squared plus 1. That's the quadratic function in standard form. By general, try to put it in the form of ax squared plus bx plus c. So let's multiply out. S minus 2 squared is s minus 2 times s minus 2. If we distribute, we get x squared minus 2x plus 4. Combine like terms, we get x squared minus 4x plus 4. Plug in, put it here. We have negative 3 times x squared minus 4x plus 4 plus 1. Then distribute negative 3. We get negative 3x squared plus 12x minus 12 plus 1. Combine like terms, we get negative 3x squared plus 12x minus 11. That's the final answer. In general, write the final answer in the form of ax squared plus bx plus c. Next example. The vertex of the parabola is the point negative 3, negative 2. And the point on the parabola is negative 1, negative 6. Find the quadratic function. First step, plug in vertex for h and k. We get a times x minus h plus k. The standard form is a times x minus h squared plus k. That's the standard form. Plug in h and k. Next, plug in the given point to find a. Next, plug in the given point to find a. For the given point, negative 1 represents x, negative 6 represents y. So plug in negative 6 for y. In general, f of x is y. Here x is negative 1. Minus negative 3, double negative is positive. Minus 2. In the parentheses here, negative 1 plus 3 is 2. 2 squared is 4. So we get negative 6 equal to 4a minus 2. Next, we can add 2 to both sides. If I add 2 to both sides, I get negative 4 equal to 4a. Then I can divide both sides by 4. If I divide both sides by 4, I get a equal to negative 1. Then we plug in negative 1 for letter a. We get f of x equal to negative 1 times x minus negative 3, double negative is positive. Negative 1 times x plus 3 squared minus 2. Then simplify. Let's expand the perfect square first. X plus 3 squared equal to x plus 3 times x plus 3. Distribute, we get x squared plus 3x plus 3x plus 9. That's x squared plus 6x plus 9. So that's the perfect square. Put it here. I get negative 1 times x squared plus 6x plus 9 minus 2. Next, distribute negative 1. We get negative x squared minus 6x minus 9 minus 2. Then combine like terms. We get negative x squared minus 6x minus 11. That's the final answer. F of x is negative x squared minus 6x minus 11. Next example. The vertex of the parabola is the point negative 4, 5. And the point on the parabola is negative 5, 9. Find the quadratic function. So first step, we plug in the vertex for h and k. First step, plug in the vertex for h and k. So f of x is a times x minus h squared plus k. Here h is negative 4, k is 5. Next, plug in the given point to solve for a. Plug in the given point to solve for letter a. For the given point, negative 1 represents x, and 9 represents y. In general, y is the same as f of x. So plug in 9 for f of x. X is negative 5. X is negative 5. Minus negative 4. Double negative is positive. Next, solve this equation for letter a. do the parentheses first. In the parentheses, -5 plus 4 is -1. -1 squared is +1. And we know that a times 1 is a. Next, I can subtract 5 from both sides. If I subtract 5 from both sides, I get a equal to 4. Then we plug in 4 for letter a. We get f of x equal to 4 times x plus 4 squared plus 5. Plug in 4 for letter a. Then expand the perfect square. S plus 4 squared is s plus 4 times s plus 4. If we distribute, we get s squared plus 4x plus 16. If I combine like terms, we get s squared plus ax plus 16. Then put it here. We have 4 times x squared plus ax plus 16 plus 5. Distribute 4, we get 4x squared plus 32x plus 64 plus 5. Then combine like terms, we get 4x squared plus 32x plus 69. That's the quadratic function. In general, put the answer in the form of ax squared plus bx plus c. Next, let me show you how to write a quadratic function in a standard form. For example, f of x equal to x squared plus 4x plus 9. How can we write this function in the standard form? The standard form of quadratic function looks like this. A times x minus h squared plus k. How can we write this function in the standard form? In order to write a quadratic function in standard form, we can try to complete squares. Let's try to complete squares for x. So first step, group x together. We get x squared plus 4x and plus 9. First step, group x together. Next, we try to add a term here to make a perfect square trinomial. A perfect square trinomial looks like this. It's either a squared plus 2ab plus b squared. That equal to a plus b squared. Or a squared minus 2ab plus b squared. That equal to a minus b squared. They are called perfect square trinomial. We try to add a term here to make this a perfect square trinomial. So what can we do here? First step, take a middle number, which is positive 4. Positive 4 divided by 2 is positive 2. Then we square this number. Positive 2 squared is 4. So this 4 represents b squared. We have a squared plus 2ab. This 4 here represents b squared. So I F4 to make a perfect square trinomial. F4 here to make a perfect square trinomial. But when we F4, we need to subtract 4 at the same time to keep it in balance. Now, factor the first return. Factor the first return. X squared plus 4x plus 4. If we factor correctly, it should be a perfect square trinomial. Find two numbers. First of all, put x on the parentheses. Find two numbers, then multiply to be 4 and add to be 4. Find two numbers, then multiply to be 4 and add to be 4. The only possibility is positive 2 and positive 2. 2 times 2 is 4, and 2 plus 2 is also 4. This is x plus 2 squared. So this perfect square trinomial can be written as s plus 2 squared. Minus 4 stays the same, plus 9 stays the same. And for this perfect square trinomial, a shortcut is we can directly use this number to make a perfect square trinomial. We can directly use this number, plus 2. I can directly put plus 2 here, right? X plus 2 squared. That's a quicker way to write this as a perfect square. Here, negative 4 plus 9 is positive 5. That's in the standard form. This is in the standard form. Right here, a is 1. Here, letter a is 1. This is in the standard form. Next example, f of x equal to x squared minus 6x plus 3. How can we write this quadratic function in standard form? Same procedure. First step, we group x together. Next, try to add a term here to make perfect square trinomial. What we can do is take negative 6, divide by 2, we get negative 3. Then square this number. Negative 3 squared is positive 9. So I can add 9 here to make perfect square. Add 9 here to make perfect square trinomial. But when we add 9, we need to subtract 9 at the same time to keep in balance. When we add 9, we need to subtract 9 at the same time to keep in balance. Next, factor the first 3 terms here. As a shortcut, we can use this number directly to make perfect square trinomial. We can write it as x minus 3 squared. Minus 9 stays the same, plus 3 stays the same. For this perfect square trinomial, we can use this number directly to make perfect square. We get s minus 3 squared. We can check the answer. For these 3 terms, x squared minus 6x plus 9. If we try to factor this trinomial, we first of all put x in the parentheses. Next, try to find two numbers that they multiply to be 9 and then add to be negative 6. The only possibility is negative 3 and negative 3. Negative 3 times negative 3 is positive 9. And negative 3 plus negative 3 is negative 6. So that's how we factor this trinomial. X minus 3 times x minus 3 is x minus 3 squared. We get exactly the same answer. So we can use this number directly to make perfect square here. Next, adding up, negative 9 plus 3 is negative 6. That's how we write this function in the standard form. Next example, f of x equal to 2x squared plus 4x minus 1. How can we write this in standard form? So, first step, we group x together. First step, group x together. Now, if there's a coefficient in front of x squared, factor this number out. If I factor 2 out, I get x squared plus 4 divided by 2 is 2. 4 divided by 2 is 2. I get 2x. Here, 4 divided by 2 is 2. I get 2x minus 1. Next, try to make perfect square here. So take the middle number, positive 2. Positive 2 divided by 2 is positive 1. Next, square this number. Positive 1 square is 1. So I can add 1 here to make perfect square trinomial. I get x squared plus 2x plus 1. When we add 1, we need to subtract 1 at the same time to keep it in balance. Then, factor these 3 terms. X squared plus 2x plus 1. We can directly use this number to make perfect square. Positive 1, I get x plus 1 squared minus 1. Remember, this 2 is in front of this entire parenthesis. So you get 2 times the perfect square minus 1. This 2 is in front of the entire parenthesis. So you get 2 times s plus 1 squared minus 1. Next, distribute 2. Distribute 2. We get 2 times s plus 1 squared minus 2 minus 1. Combine like terms. I get 2 times s plus 1 squared minus 3. That's how we write this function in standard form. Next example. F of x equal to 3x squared minus 18x plus 4. How can we write this function in the standard form? So, first step, we try to group x together. Next, if there's a coefficient in front of x, we need to factor this out. If I pull out 3, I get 3 times s squared. Negative 18 divided by 3 is negative 6. I get negative 6s here. Next, try to add a term here to make perfect square. What should we add? Take the middle number, negative 6. Negative 6 divided by 2 is negative 3. Then negative 3 squared is positive 9. So I can add 9 to make perfect square trinomial. Add 9 here to make perfect square trinomial. When we add 9, we need to subtract 9 at the same time to keep it in balance. Now, factor these 3 terms. S squared minus 6x plus 9. I can use this number to make perfect square trinomial. I can write it as x minus 3 squared minus 9. This 3 is in front of everything. Plus 4. Next, distribute number 3. Distribute number 3. We get 3 times x minus 3 squared. 3 times 9 is 27 plus 4. That's 3 times x minus 3 squared minus 23. That's how we run this function in the standard form. That's in the standard form. A times x minus h plus k. A times x minus h squared plus k. That's in the standard form. Next example. F of x equal to negative x squared plus ax minus 7. How can we run this function in the standard form? First step, group x together. We get negative x squared plus ax minus 7. Next, if there's a number in front of x, try to factor this number out. If I pull out negative 1, consider there's a negative 1 here. If I pull out negative 1, I have x squared. Positive a divided by negative 1 is negative a. So factor out the number in front of x squared. Next, try to make perfect square here. So in order to make perfect square, take the middle number. Take negative a divided by 2, we get negative 4. Then negative 4 squared is 16. So in order to make perfect square trinomial, add 16 here. While I add 16, I need to subtract 16 at the same time to keep it in balance. Next, factor the first 3 terms. S squared minus ax plus 16. This is a perfect square trinomial. I can use this number to make perfect square quickly. That's x minus 4 squared. Minus 16 stays the same. This negative 1 is in front of the entire parentheses. So keep negative 16 inside the bracket. Minus 7. We can check the answer here. X squared minus ax plus 16. If we factor this in the normal way, I first put x in the parentheses. Since this is a trinomial with no leading coefficient, I first put x in the parentheses. Next, find 2 numbers that they multiply to be 16 and add to be negative a. Find 2 numbers that they multiply to be 16 and add to be negative a. The only possibility is negative 4 and negative 4. So after factoring, we get s minus 4 times s minus 4, which is s minus 4 squared. That's exactly the same as what we have here. Next, distribute negative 1. We get negative x minus 4 squared plus 16 minus 7. That's negative x minus 4 squared plus 9. Next example, f of x is negative x squared minus 10x plus 5. How can we complete square for this quadratic function? First step, we group x together. Negative x minus 10x plus 5. Next, if there's a coefficient in front of x squared, we need to factor out the coefficient. Here, consider there's a negative 1 in front of x squared. So factor negative 1 out. If we factor negative 1 out, we get x squared. Negative 10 divided by negative 1 is positive 10. Next, we try to add a term here to make perfect square trinomial. So here I can take positive 10 divided by 2, which is positive 5. Then square this number. Positive 5 squared is 25. So I can add 25 here to make a perfect square trinomial. When we add 25, we must subtract 25 at the same time to keep it in balance. Next, factor this perfect square trinomial. A shortcut is we can use this number to make perfect square. Use x, we can make x plus 5 squared. Negative 25 stays the same. We can check an answer here. For x squared plus 10x plus 25. This is a trinomial with no leading coefficient, so we can draw two parentheses. Put x on each parentheses, and then we can find two numbers. Multiply to be 25, and then add to be 10. The only possibility is positive 5 and positive 5. 5 times 5 is 25, and then 5 plus 5 is 10. So we get x plus 5 times x plus 5, which is x plus 5 squared. It's exactly the same as what we have here. So a shortcut is use this number to make perfect square. Then distribute negative 1. Distribute negative 1. We get negative x plus 5 squared. Negative 1 times this is negative x plus 5 squared. And negative 1 times negative 5. Negative 1 times negative 25 is positive 25. And then combine like terms. 25 plus 5 is 30. That's how we complete square for this quadratic function. Next example. F of x equal to negative 2x squared plus ax plus 5. In order to complete square, first step, we group x together. Negative 2x squared plus ax plus 5. Next, if there's a coefficient in front of x squared, pull out, factor out this coefficient. If I factor negative 2 out, what's left is x squared positive a divided by negative 2 is negative 4. Next, we have to add a term here to make a perfect square trinomial. So take the middle number. Negative 4 divided by 2 is negative 2. Then square this number. Negative 2 squared is positive 4. So I can add 4 and F4 here to make a perfect square trinomial. Whenever I add 4, I need to subtract 4 at the same time to keep it in balance. Then factor these three terms. That's a perfect square trinomial. I can factor these three terms using this number. That's a shortcut. I can write it as x minus 2 squared minus 4 plus 5. We can check. If we have x squared minus 4x plus 4, this is a perfect square trinomial. There's no leading coefficient in the front. I can write x in the front first, in the parentheses first, and then find two numbers that they multiply to be positive 4 and they add to be negative 4. The only possibility is negative 2 times negative 2. Negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. So we get x minus 2 times x minus 2, which is x minus 2 squared. That's exactly what we have here. Next, distribute negative 2. We get negative 2 times x minus 2 squared. Negative 2 times negative 4 is positive a. Negative 2 times negative 4 is positive a. Keep positive 5 the same. Then combine like terms. We get negative x squared, negative x minus 2 squared plus 13. That's the standard form of this quadratic function. That's the standard form of this quadratic function. Next example. F of x equal to negative 4x squared plus 24x plus 10. How can we complete square of this function? First step, group x together. Write negative 4x squared plus 24x plus 10. If there's a coefficient in front of x squared, factor this coefficient out first. If I factor negative 4 out, I get x squared by itself. For the second term, positive 24 divided by negative 4 is negative 6. Next, try to add a term here to make this a perfect square trinomial. So I take the middle number, negative 6 divided by 2, which is negative 3. Negative 3 squared is positive 9. So I can add 9 here to make perfect square trinomial. But when we add 9, we need to subtract 9 at the same time to keep it in balance. Then factor this 3 term. Since this is a perfect square trinomial, we know the answer must be a perfect square. We can use this number to write it as a perfect square. We get x minus 3 squared and leave negative 9 by itself, plus 10. Next, distribute negative 4. We get negative 4 times x minus 3 squared. Negative 4 times negative 9 is positive 36. Combine like terms. 36 plus 10 is 46. That's the standard form of this quadratic function. Next example. F of x equal to x squared plus 3x plus 2. How can we write this quadratic function in the standard form? First step, we group x together. Next, try to add a term here to make this a perfect square trinomial. So, take a middle number, which is positive 3, divided by 2. Positive 3 divided by 2, that's not divisible. That's positive 3 over 2. Next, square this number. Positive 3 over 2, when we square, we get positive 9 over 4. So, add this number here. We get x squared plus 3x plus 9 over 4. But when we add 9 over 4, we have to subtract 9 over 4 at the same time to keep in balance. Then factor these 3 terms. The first 3 term is a perfect square trinomial. We can use this number to draw a perfect square. So it can be written as x plus 3 over 2 squared minus 9 over 4 plus 2. Then combine like terms. Negative 9 over 4 plus 2. Number 2 can be rewritten as 2 over 1. Then find common denominator. For 4 and 1, the common denominator is 4. So I multiply top and bottom by 4. I get negative 9 over 4 plus a over 4. Negative 9 over 4 plus a over 4 is negative 1 over 4. That's how we write this function in the standard form. Next example. F of x equal to x squared minus 5x plus 4. How can we write this function in the standard form? First step, we group x together. Write it as x squared minus 5x plus 4. Next, we try to add a number here. To make perfect square trinomial. So what we can do is take the middle number, negative 5 divided by 2. 5 divided by 2 is not divisible, so I leave it as 5 over 2, negative 5 over 2. Then we square this number. Negative 5 over 2, when we square, double negative is positive. We get positive 25 over 4. So add this number to make perfect square trinomial. Plus 25 over 4. When we add 25 over 4, we need to subtract 25 over 4 at the same time to keep in balance. Then factor the first 3 terms. If we factor the first 3 terms, it must be a perfect square trinomial. This is a perfect square trinomial, so if we factor, it must be a perfect square. We can use this number to write it as a perfect square. That's a shortcut. we can write it as x minus 5 over 2 square. Use this number to make perfect square. That's a shortcut. Minus 25 over 4 plus 4. Combine like terms, we get x minus 5 over 2 square, negative 25 over 4 plus 4. First step, we need to find common denominator. So I first of all rewrite 4 as 4 over 1. Common denominator is 4. So I multiply top and bottom by 4, which is negative 25 over 4 plus 16 over 4. Negative 25 over 4 plus 16 over 4 is negative 9 over 4. So combine like terms, I get negative 9 over 4. That's how we write this function in the standard form. Next example, f of x equal to 2x squared plus 3x minus 6. How can we write this quadratic function in the standard form? So first step, we group x together. Write it as 2x squared plus 3x minus 6. If there's a coefficient in front of x squared, always factor this coefficient out first. So if I factor 2 out, I get x squared by itself. For the second term, if I factor 2 out, I take 3 divided by 2. I get 3 over 2x. For the second term, I take 3 divided by 2, which is 3 over 2x. Factor 2 out, get x squared by itself. Next, try to add a term here to make perfect square trinomial. So what we can do is take the middle number. Middle number is positive 3 over 2. Take the middle number, divide by 2. Take the middle number, divide by 2. Positive 3 over 2 divided by 2. 2 can be rewritten as 2 over 1. When we divide, we keep the top the same. Flip the bottom over. We get negative 3 over 2 times 1 over 2. If I multiply, I get negative 3 over 4. So if I take the middle number, divide by 2, I get negative 3 over 4. Next, square this number. Negative 3 over 4, if I square, I get positive 9 over 16. So add this number here to make a perfect square trinomial. We get 2 times s squared plus 3 over 2x plus 9 over 16. When we add 9 over 16, we need to subtract 9 over 16 at the same time to keep in balance. Then factor the first return. The first return is a perfect square trinomial. We can factor the first return using this number here. We can factor the first return using this number. So I can write it as negative x minus 3 over 4 squared. And this number stays the same. Minus 9 over 16 minus 6. Next, distribute 2. If I distribute 2, I get x minus 3 over 4 squared minus 2 times 9 over 16. What do we get? 2 times negative 9 over 16. What do we get? If we multiply, we can write 2 as 2 over 1 times negative 9 over 16. For 2 and 16, I can divide both numbers by 2. I get 1 and a, and then multiply. On the top, 1 times negative 9 is negative 9. On the bottom, 1 times a is a. So we get negative 9 over a. Then combine like terms. Take negative 9 over a minus 6. Combine like terms. Take negative 9 over a minus 6. Negative 9 over a minus 6. 6 can be rewritten as 6 over 1. Next, find a common denominator. For a and 1, the common denominator is a. So I can multiply both top and bottom by a. I get negative 9 over a minus 48 over a. Negative 9 minus 48 is negative 57 over a. So if I combine like terms, I get negative 57 over a. That's the standard form of this quadratic function. Next example, f of x equal to negative 4x squared plus 5x minus 1. How can we write this function in the standard form? First step, we group x together. Write it as negative 4x squared plus 5x minus 1. If there's a coefficient in front of x, if there's a coefficient in front of x squared, pull it out. Pull out negative 4. If I pull out negative 4, I get x squared by itself. For the second term, we take positive 5 divided by negative 4. Positive 5 divided by negative 4. Positive number divided by negative number is negative. 5 divided by 4 is not divisible, so I write it as 5 over 4x minus 1. Next, try to add a term here to make perfect square, trinomial. So I take the middle number, negative 5 over 4. Take the middle number, divide by 2. Take the middle number, divide by 2. Negative 5 over 4 divided by 2. 2 can be rewritten as 2 over 1. When we divide, we keep the top the same. Flip the bottom over. Then multiply the top to the top, bottom to the bottom. We get negative 5 over 8. Next, take this number, square. Negative 5 over 8. If we square, we get 25 over 64. So add this number here to make perfect square trinomial. I get negative 4 times s squared minus 5 over 4x plus 25 over 64 minus 25 over 64 minus 1. Next, factor the first three terms. The first three terms is a perfect square trinomial. If we factor, we can use this number to write the perfect square. We can write it as x minus 5 over 8 squared. That's a shortcut. We can use this number to write the perfect square. Minus 25 over 64 minus 1. Next, distribute negative 4. Distribute negative 4. If I distribute negative 4, I get negative 4 times x minus 5 over 8 squared. Then take negative 4 times negative 25 over 64. Negative 4 times negative 25 over 64. I can first of all rewrite negative 4 as negative 4 over 1 times negative 25 over 64. For 4 and 64, I can divide both numbers by 4. I get negative 1 here, 16 here. On the numerator, negative 1 times 25 is positive 25. On the bottom, 1 times 16 is 16. So I get positive 25 over 16. If I distribute, I get positive 25 over 16 minus 1. Next, combine like terms. Combine like terms. 25 over 16 minus 1, what do we get? 25 over 16 minus 1, I can first of all rewrite 1 as 1 over 1. Then find their common denominators. For 16 and 1, the common denominator is 16. So here I can multiply top and bottom by 16. I get 25 over 16 minus 16 over 16. Then to the numerator, 25 minus 16 is 9. So I get 9 over 16. So combine like terms, I get 9 over 16. That's how I write this function in the standard form. Next example, f of x equal to 3x squared minus 7x plus 3. How can we write this quadratic function in the standard form? First step, we group x together. We get 3x squared minus 7x plus 3. If there's a coefficient in front of x squared, always pull out this coefficient. So here, pull out 3. If I factor 3 out, I get x squared by itself. For the second term, we take 7 divided by 3. 7 divided by 3 is not divisible, so I write it as 7 over 3. x. Next, try to add a term here to make perfect square trinomial. So take middle number, -7/3 divided by 2. For 2, I can write it as 2/1. -7/3 divided by 2, I can write it as -7/3 times the reciprocal 1/2. If I multiply, I get -7/6. Then square this number. -7/6, if I square, I get 49/36. -7/6, if I square, I get 49/36. Then add this number here to make perfect square trinomial. I get 3 times s squared minus 7/3x plus 49/36. When we add this number, we need to subtract this number at the same time to keep it in balance. Next, factor these 3 terms. This is a perfect square trinomial. If I factor, I must get a perfect square. This is a perfect square trinomial. If I factor, I must get a perfect square. I can use this number to write a perfect square. So I can write it as x minus 7/6 squared minus 49/36 plus 3. Next, if I distribute 3, I get 3 times x minus 7/6 squared minus 3 times -49/36. What do we get? Three times -49/36. I can first of all rewrite number 3 as 3/1. Then I can divide top and bottom by 3. 3 divided by 3 is 1. 36 divided by 3 is 12. Together we get -49/12 plus 3. Don't forget 3. Next, combine like terms. We get 3 times x minus 7/6 squared. -49/12 plus 3. What do we get? -49/12 plus 3. I can first of all rewrite 3 as 3/1. And then find the common denominator. For 12 and 1, the common denominator is 12. So I multiply top and bottom by 12, which is -49/12 plus 36/12. Then add the numerator. -49 plus 36 is -13. I get -13/12. That's the standard form of this quadratic function. Next example. F of x equal to -5x squared plus 3x minus 2. How can we write this quadratic function in the standard form? First step, we group x together. Right, -5x squared plus 3x minus 2. Next, if there's a coefficient in front of s squared, always pull on this coefficient. So pull on -5, get s squared by itself. If I pull out -5, for the second term here, we take +3 divided by -5. +3 divided by -5. Positive number divided by negative number is negative. 3 divided by 5 is 3/5. Next, try to add a number here to make perfect square trinomial. Try to add a number here, add a term here to make perfect square trinomial. So I take the middle term. -3/5 divided by 2. -3/5 divided by 2. 2 can be rewritten as 2/1. That's -3/5 times the reciprocal, which is 1/2. If I multiply, we get -3/15 or -3/10. If I multiply, I get negative 3 over 10. Next, square this number. Negative 3 over 10. If I square, I get 9 over 100. Then, add this number here to make a perfect square trinomial. We get negative 5 times s squared minus 3 over 5x plus 9 over 100 and minus 9 over 100 at the same time to keep in balance. When we add 9 over 100, we need to subtract 9 over 100 at the same time. Minus 2 stays the same. Then, factor this perfect square trinomial. If I factor these three terms, this is a perfect square trinomial. If I factor, it must be a perfect square. I can use this number as a shortcut. I can write it as x minus 3 over 10 square minus 9 over 100 minus 2. Then distribute negative 5. I get negative 5 times x minus 3 over 10 square. Then take negative 5 times negative 9 over 100. Negative 5 times negative 9 over 100. If I distribute, take negative 5 times negative 9 over 100. So first of all, I will write negative 5 as negative 5 over 1. First step, we write negative 5 as negative 5 over 1 times negative 9 over 100. For 5 and 100, I can divide both numbers by 5. I get negative 1 and 20 here. If I multiply, I get negative 1 times negative 9 is positive 9. On the bottom, 1 times 20 is 20. So if I multiply, I get 9 over 20. Negative 5 times negative 9 over 100, I get 9 over 20 minus 2. Next, combine like terms. 9 over 20 minus 2. If I combine like terms, 9 over 20 minus 2. Positive 9 over 20 minus 2. I first of all rewrite 2 as 2 over 1. Then find the least common denominator. For 20 and 1, the least common denominator is 20. So I can multiply top and bottom by 20. I get 9 over 20 minus 40 over 20. Then I can subtract the numerator. 9 minus 40 is negative 31. I get negative 31 over 20. If I combine like terms, I get negative 31 over 20. That's the standard form of this quadratic function. Next, let me show you how to write the general quadratic function in the standard form. This function here, ax squared plus bx plus c, this is called the general quadratic function. We try to rewrite this function in the standard form. So, first step, we group x together. We get ax squared plus bx plus c. If there's a coefficient in front of s squared, always pull out a coefficient. If there's a coefficient in front of s squared, always pull out a coefficient. If I pull out a, I get s squared plus b divided by a is not divisible. So I leave it as b over a. So I get s squared plus b over ax plus c. Next, we try to add one term here to make a perfect square trinomial. Try to add one term here to make a perfect square trinomial. So what we can do is take the middle coefficient, take the middle number, divide by 2. Take the middle number, positive b over a, divide by 2. b over a divided by 2, I can first of all rewrite 2 as 2 over 1. When we have a fraction divided by another fraction, we keep the top fraction the same. Flip the bottom fraction over. Then multiply 3 across. b times 1 is b. On the bottom, a times 2 is 2a. So we get b over 2a. Next, square this number. b over 2a, if I square this number, b over 2a, if I square, I get b squared over 4a squared. If I square this number, I get b squared over 4a squared. Next, add this number here to make perfect square trinomial. I get a times x squared plus b over ax plus b squared over 4a squared. But when we add a number, we need to subtract the number at the same time to keep in balance. So minus b squared minus 4a squared plus c. Then factor these three terms. We know that this three terms is a perfect square trinomial. We can use this number to write a perfect square. If I factor, I get x plus b over 2a. I can use this number to make perfect square. Minus b squared over 4a squared plus c. Next, distribute letter a. Distribute letter a. I get a times x plus b over 2a squared. Here we take a times b squared over 4a. Take a times negative b squared over 4a. What do we get? A times negative b squared over 4a squared. I can first of all rewrite letter a as a over 1 times negative b squared over 4a squared. I can cancel one of the letter a from top and bottom. If I cancel letter a, I get 4a here. Then multiply the top to the top, bottom to the bottom. I get negative b squared over 4a. So if I distribute letter a, I get negative b squared over 4a plus c. Next, combine like terms. Combine like terms. We get a times x plus b over 2a squared. If I combine like terms, I get negative b squared over 4a plus c. I can first of all rewrite c as c over 1. Then for 4a and 1, the least common denominator is 4a. So I can multiply top and bottom by 4a. If I multiply, I get negative b squared over 4a plus 4ac over 4a. Next, we can add the numerator to the numerator, denominator to the denominator. On the numerator, I get 4ac minus b squared. Denominator is 4a. So if I combine like terms, I get 4ac minus b squared over 4a. That's the standard form of the general quadratic function. That's the standard form of the general quadratic function. Now, if we compare this function with the standard form of quadratic function, f of x equal to a times x minus h squared plus k. If we compare this function with the standard form of quadratic function, we can see that this a and this a, they're exactly the same thing. So, for the function, for quadratic function in the standard form, in the general form, this a and this a, they're exactly the same. For quadratic function in the general form or standard form, this a and this a, they're exactly the same. H is negative b over 2a. Since this h is negative, so h is negative b over 2a. K is this 4ac minus b squared over 4a. If we compare the standard form and the general form, we can see that here h is negative b over a, b over 2a. K is 4ac minus b squared over 4a. So we can say that for quadratic function in the general form, its vertex is negative b over 2a, comma 4ac minus b squared over 4a. Because in the standard form, h and k represent a vertex. Here h is negative b over 2a, and k is 4ac minus b squared over 4a. That's the vertex for quadratic function in the general form. That's the vertex for quadratic function in the general form. And for axis of symmetric, it's always in the form of x equal to h. The axis of symmetry is always in the form of s equal to h. Here h is negative b over 2a. That's the axis of symmetric. That's axis of symmetry. That's an axis of symmetry for quadratic function in the general form. It's always x equal to negative b over 2a. So keep this formula in mind. Next, let me show you how to graph quadratic functions. Graph each of the following quadratic functions and find the maximum or minimum values. First example, f of x equal to x squared minus 4x plus 3. How can we graph this quadratic function? We know that the graph of quadratic function is always a parabola. It's either open upward or open downward. If it's open upward, it has a minimum and a vertex. If it's open downward, it has a maximum and a vertex. So let's graph this function, f of x equal to x squared minus 4x plus 3. In order to graph a quadratic function, we need to know the x and y intercepts, the axis of symmetry, and the vertex. Let's find x-intercepts first. For x-intercept, we set y equal to 0. In general, y is f of x, so set the entire function equal to 0. Solve for x. Set y equal to 0, solve for x. If we flatten the function, we first of all draw two parentheses. Put x on each parenthesis. Then find two numbers that multiply to be 3, add to be negative 4. Here we have negative 3 and negative 1. Then we have x minus 3 equal to 0, s minus 1 equal to 0. Which means s equal to 3 and s equal to 1. Those are the s-intercepts. 3, 0, and 1, 0. For s-intercept, the y-coordinate is always 0. Now, for the y-intercept, we set s equal to 0, solve for y. So plug in 0 for x, find y. Y-intercept is f of 0. Y-intercept is f of 0. Plug in 0 for x. We get 0 squared minus 4 times 0 plus 3 equal to 3. So the y-intercept is 0, 3. Those are the s-intercepts and the y-intercept. Next, find the axis of symmetry. For axis of symmetry, the formula is h equal to s equal to negative b over 2a. That's the formula for axis of symmetry. S equal to negative b over 2a. In the function here, a equal to 1, b equal to negative 4, c equal to 3. So plug in. For axis of symmetry, s equal to negative b over 2a. b is negative 4, so you get negative 4 over 2a. A is 1. So in the numerator, double negative is positive. We get 4. In the denominator, 2 over 1 is 2. We get 2. So axis of symmetry is s equal to 2. Next, find a vertex. How do we find a vertex? For vertex, we need to find h and k. H is negative b over 2a, which is the same as x here, negative b over 2a, which is 2. For k, we can use this formula. For 4ac minus b squared all over 4a. For k, we can use this formula here. 4ac minus b squared over 4a. If we use the formula k equal to 4ac minus b squared over 4a, we get k equal to 4 times a is 1, times c is 3, minus b squared, b is negative 4, all over 4a is 1. If we plug in, we get 4 times 1, that's 4. 4 times 3 is 12. Minus negative 4 squared is 16. In the denominator, 4 times 1 is 4. Then in the numerator, 12 minus 16 is negative 4. Denominator is 4. Negative 4 over 4 is negative 1. So, using this formula is okay, but this formula may be too complicated. An easier way for k is we plug in this number 2 into the original function. Plug in this number 2, h, into the original function. Because the vertex h and k, there's a point on the curve, so it must satisfy this equation. There's a point on the curve, it must satisfy this equation. So I can plug in h into the original function and find k. If I plug in 2 here, I get 2 squared minus 4 times 2 plus 3. 2 squared is 4. 4 minus 2 is a plus 3. 4 minus a is negative 4. Negative 4 plus 3 is negative 1. So the vertex is 2 comma negative 1. The vertex is 2 comma negative 1. Now let's sketch the graph. Before we sketch the graph, one more thing here. Since a is positive, the curve, the parabola is open upward. Also, a equal to 1. That means the parabola is open upward. Keep in mind that when a is positive, parabola is open upward. When a is negative, the parabola is open downward. Here a is 1, which is positive, so the parabola is open upward. Now, based on this information, sketch the graph. X-intercept is 3, 0, 1, 0. That's X-intercept 3, 0, 1, 0. Y-intercept is 0, 3. That's a Y-intercept. Axis of symmetry is s equal to 2. That's axis of symmetry. Vertex is 2, negative 1. Then, based on this information, sketch a graph. We know that parabola is open upward. A is positive, means parabola is open upward. So parabola open upward, going through this point. That's how we graph the parabola. So in order to graph a parabola, we find x and y intercepts first. Then we find axis of symmetry. Then find the vertex. Then determine if the parabola is open upward or downward. Then based on this information, sketch a graph. Next, find the maximum or minimum value. Since this parabola is open upward, it has a minimum. Since this parabola is open upward, it has a minimum. So f minimum represents minimum of function f. F minimum represents minimum of function f. Minimum located at the vertex. And for maximum minimum, always use the y coordinate. For maximum minimum, always use the y coordinate. At this point here, the y coordinate is -1. At this point here, the y coordinate is -1. So that's the minimum value of this quadratic function. That's the minimum value of this quadratic function. Next example, f of x equal to -x squared plus 2x plus 3. How can we graph this quadratic function? In order to graph this quadratic function, we find the x and y intercepts first. For x-intercept, we set y equal to 0, which means set the entire function equal to 0. We get -x squared plus x plus 2x plus 3 equal to 0. Here, since x squared is negative, I can divide both sides by -1 to make it positive. It will be a little easier. If I divide both sides by -1, I can make a positive 1 here. It will be a little easier. If I divide both sides by -1, I get x squared minus 2x minus 3 equal to 0. Then solve the equation by factoring. This is a trinomial with no leading coefficient. I can put x on each parentheses, then find two numbers that multiply to be -3 and add to be -2. Here we can use -3 and +1. Then solve the equation. We get x minus 3 equal to 0, x plus 1 equal to 0, which means s equal to 3 and s equal to -1. Those are the x-intercepts, 3, 0 and -1, 0. Next, for the y-intercept. For the y-intercept, we set s equal to 0. For the y-intercept, set s equal to 0, plotting 0 for x. Y equal to f of 0. So plotting 0 for x, we get -0 squared plus 2 times 0 plus 3. -0 squared is 0. 2 times 0 is 0 plus 3 equal to 3. So the y-intercept is 3, 0, 0, 3. For y-intercept, s coordinate is 0. So y-intercept is 0, 3. Next, find the axis of symmetry. Axis of symmetry is s equal to -b over 2a. For axis of symmetry, s is -b over 2a. In this quadratic function here, a is -1, b is +2, c is 3. So plug in, we get -2 over 2 times -1. Here b is 2, a is -1. So we get -2 over -2, which is +1. That's an axis of symmetry. Next, find the vertex. We know that for vertex, h is the same thing. H is also -b over 2a. For the vertex, h is also -b over 2a, which is 1. For k, we can use this formula, or we can use f of 1. We can plug in number 1 into the original function. We can plug in this number into the original function. That's a little easier. Plugging this number is easier than using this formula. If I plug in 1 into the original function, we get -1 squared plus 2 times 1 plus 3. That's -1 plus 2 plus 3, which is +4. So the vertex is 1, 4. The vertex is 1, 4. Also here, a is -1, which is less than 0. A is a negative number. That means the parabola is open downward. A is negative means the parabola is open downward. If A is positive, parabola is open upward. If A is negative, parabola is open downward. Now, based on this information, let's sketch the graph. X-intercept is 3, 0 and -1, 0. Those are the X-intercepts. Y-intercept is 0, 3. Axis of symmetry is s equal to 1. That's axis of symmetry. Vertex is 1, 4. Vertex is 1, 4. And we know that the parabola is open downward. Then draw a parabola open downward, passing through these points. That's a graph of this quadratic function. And we know that since A is open downward, since A is negative, parabola is open downward, it has a maximum. The maximum located at the vertex. And for maximum minimum, always use the y-coordinate. At this point, the y-coordinate is 4. At this point, at the vertex, x-coordinate is 1, y-coordinate is 4. For maximum minimum, always use the y-coordinate. So here, f has a maximum. F sub max, that means the maximum of function f is 4. F sub max, that means the maximum of function f is 4. Next example, f of x equal to 3x squared plus 2x minus 5. How can we graph this quadratic function? In order to graph this quadratic function, we need to find the x and y intercepts first. For x-intercept, set y equal to 0. F of x represents y, so set the entire function equal to 0. We get 3x squared plus 2x minus 5 equal to 0. Then solve an equation for x. For this equation, we can try to factor this equation first. We can try to solve an equation by factoring. Using AC method. A times C is negative 15. Then try to find two numbers. Let multiply to be negative 15. Add to be positive 2. We can try positive 4 and negative 3. When we multiply, we get negative 15. When we add them, we get positive 2. So I can rewrite the middle term using these two numbers. I get 3x squared plus 5x minus 3x minus 5 equal to 0. Leave the first term and last term the same. Rewrite the middle term using these two numbers. Then factor by grouping. For the first two terms, take a common factor. The only common factor here is x. If I pull x, I get 3x plus 5. For the second half, for 3 and 5, common factor is 1. Since leading term is negative, pull out negative. So I have negative 1. I use negative 1 as common factor. If I pull out negative 1, negative 3 divided by negative 1 is positive 3. Negative 5 divided by negative 1 is positive 5. And here we can see that 3x plus 4 is a common factor. If I pull out 3x plus 5, what's left is x minus 1. Then set each of them equal to 0. We get s equal to 3x equal to negative 5. S equal to negative 5 over 3. For the other equation, s equal to 1. So s-intercept is negative 5 over 3, 0. And 1, 0. Those are the s-intercepts. For the y-intercepts, we set s equal to 0, which means plug in 0 for x. Y equal to f of 0, which is 3 times 0 squared plus 2 times 0 minus 5, which is 0 plus 0 minus 5 equal to negative 5. So the y-intercept is 0, negative 5. Those are the s and y intercepts. Next, find the axis of symmetry. Find the axis of symmetry. For the axis of symmetry, The formula is S equal to negative B over 2A. Here, A is 3, B is 2, C is negative 5. Here, plotting A and B, I get negative B, which is negative 2, over 2 times A is 3. I get negative 2 over 6. For 2 over 6, I can divide top and bottom by 2, make negative 1/3. So, axis of symmetry is S equal to negative 1/3. Next, find the vertex. For the vertex, H is also negative B over 2A, so which is also negative 1/3. For K, we can plug in H into the original function. For K, we plug in H into the original function. We get f of negative 1/3. Plugging negative 1/3 here, we get 3 times negative 1/3 squared plus 2 times negative 1/3 minus 5. Negative 1/3 squared is 1 over 9. 2 times negative 1 over 3 minus 5. Now next we multiply. 3 times 1 over 9 is 3 over 9. That's the same as 1/3. 2 times negative 1/3 is negative 2/3. 1/3 plus negative 2/3 is negative 1/3. Negative 1/3 minus 5. I can rewrite 5 as 5 over 1. Then find common denominator. For 3 and 1, common denominator is 3. So I can multiply top and bottom by 3. Five times 3 is 15. 1 times 3 is 3. Negative 1/3 minus 15 over 3 is negative 16 over 3. So the vertex is negative 1 over 3, comma, negative 16 over 3. That's the vertex. And also we know that A is greater than 0. A equal to 3, which is greater than 0. That means parabola is open upward. A is greater than 0 means parabola is open upward. Now, based on this information, let's sketch the graph. X-intercept is negative 5 over 3 and 1. So 1 is here, 2 is here, negative 4 is here, negative 2 is here. Negative 5 over 3 is about negative 1.6, somewhere here. 1 comma 0 is here. Those are the x-intercepts. Y-intercept is negative 5. 1, 2, 3, 4, 5, somewhere here. That's the y-intercept. Axis of symmetry is negative 1/3. Negative 1/3 is somewhere here. That's an axis of symmetry. Vertex is negative 1/3, negative 16 over 3. Negative 16 over 3 is a little more than negative 5, somewhere here. That's the vertex. That's the vertex. And we know that the parabola is open upward. Parabola is open upward. Then passing through this point, draw parabola open upward. That's the graph of the parabola. Since the parabola is open upward, we know it has a minimum. Since the parabola is open upward, it has a minimum. So for the minimum of the function, for maximum or minimum of the parabola, always use the y-coordinate and the vertex. And the vertex, that's the s-coordinate, that's the y-coordinate. So the minimum of the function is -16/3. For maximum or minimum, always use the y-coordinate in the vertex. Always use the y-coordinate in the vertex. That's -16/3. That's the minimum of the function. For maximum or minimum of a function, always use the y-coordinate. Let's see example. f of x equal to -2x squared minus 5x plus 3. We try to graph this quadratic function. So first step, find the x and y intercepts. For x-intercept, set y equal to 0, which means set the entire function equal to 0. We get -2x squared minus 5x plus 3 equal to 0. In general, if the leading coefficient is negative, we can divide both sides by -1, make it positive. If the leading coefficient is negative, we can divide both sides by -1, make it positive. So if I divide both sides by -1, I get 2x squared plus 5x minus 3 equal to 0. Next, we can try to factor this trinomial using AC method. If I use AC method, a times c, 2 times -3 is -6. Next, find two numbers that multiply to be -6 and add to be +5. We can try to use +6 and -1. +6 times -1 is -6. +6 plus -1 is +5. So these two numbers works. Once I find these two numbers, rewrite the middle term using these two numbers. I get 2x squared plus 6x minus 1x minus 3 equal to 0. Next, factor by grouping. Once we get four terms, we can factor this by grouping. For the first two terms, I can pull a common factor, 2x. If I pull out 2x, what's left is x plus 3. For the second half, I can pull a common factor, -1. If I pull out -1, I have x. -3 divided by -1 is +3. I have x plus 3. Then here we can see that x plus 3 is a common factor. If I pull out x plus 3, what's left is 2x minus 1. Then set each of them equal to 0. We get x plus 3 equal to 0, 2x minus 1 equal to 0. Solve both equations individually. If I solve the first equation, I get s equal to -3. If I solve the second equation, I can add 1 to both sides first. I get 2s equal to 1. Then I can divide both sides by 2. I get s equal to half. So x-intercepts are 3, 0, and half, 0. Those are the s-intercepts. And for the y-intercept, we plug in 0 for x. For the y-intercept, plug in 0 for x. We get y equal to f of 0. If I plug in 0 for x, I get -2 times 0 squared minus 5 times 0 plus 3. That's 0 plus 0 plus 3, which is 3. So the y-intercept is 0, 3. Those are the x-intercepts and the y-intercepts. Next, find the axis of symmetry. Find the axis of symmetry. For the axis of symmetry, the formula is s equal to -b over 2a. For the axis of symmetry, the formula is s equal to -b over 2a. Here in this function here, a is -2, b is -5, c is +3. We plug in a and b. b is -5, we get -5 over 2 times a is -2. In the numerator, double negative is positive, we get +5. In the denominator, 2 times -2 is -4, so we get -5 over 4 That's an axis of symmetry. Next, find the vertex. For the vertex, h is the same as negative b over 2a, so it's also negative 5 over 4. For k, we plug in negative 5 over 4 into an original function. Plugging negative 5 over 4 into an original function, we get f of negative 5 over 4. If I plug in, we have negative 2 times negative 5 over 4 squared minus 5 times negative 5 over 4 plus 3. Then simplify, we get negative 2 times 25 over 16, double negative is positive, minus 5 times negative 5 over 4 plus 3. Next, I can rewrite negative 2 as negative 2 over 1 times 25 over 16. I can rewrite 5 as 5 over 1 times negative 5 over 4 plus 3. If I simplify here, for 2 and 16, I can divide top and bottom by 2. I get negative 1 and a here. If I multiply top to the top, bottom to the bottom, I get negative 25 over a. For the second term, double negative is positive. In the numerator, 5 times 5 is 25. In the denominator, 1 times 4 is 4. Plus 3. 3 can be rewritten as 3 over 1. Next, find the common denominator for a, 4, and 1. For a, 4, and 1, the common denominator is a. So in the second term, I can multiply top and bottom by 2. For the last term, I can multiply top and bottom by a. So I get negative 25 over a plus 50 over a plus 24 over a. Altogether, negative 25 plus 50 is 25. 25 plus 24 is 49. So the vertex here is negative 5 over 4, comma 49 over 8. That's the vertex of the parabola. And also we know that here a is negative. A equal to negative 2, which is less than 0. That means the parabola is open downward. If a is negative, the parabola is open downward. If a is positive, the parabola is open upward. If a is negative, the parabola is open downward. Now, based on this information, let's sketch a graph. Here, X-intercept is, negative 3, comma 0. X-intercept is negative 3, comma 0, and half, comma 0. Negative 3 is here. Half is here. Those are the X-intercepts. Y-intercept is 3. It's here. That's a Y-intercept. Axis of symmetry is negative 5 over 4. Axis of symmetry is negative 5 over 4. Somewhere here. That's an axis of symmetry. Vertex is negative 5 over 4 and 49 over a. 49 over a is a little more than 6. That's a vertex. And we know that a is less than 0. Parabola is open downward. So based on this information, let's sketch a graph. That's a graph of this quadratic function. That's a graph of this quadratic function. And we know that Since the parabola is open downward, it has a maximum and a vertex. Since the parabola is open downward, it has a maximum and a vertex. For maximum or minimum, we always use the y-coordinate and a vertex. For maximum or minimum, we always use the y-coordinate and a vertex. Here in the vertex, the y-coordinate is 49 over a. So the maximum of the function f sub max is 49 over a. For maximum or minimum, always use the y-coordinate and the vertex. That's the maximum of this quadratic function. F sub max represents the maximum of function f. So, based on the previous example, we know that if we try to find the maximum or minimum of a quadratic function, we can sketch the graph, and then based on the graph, find the maximum or minimum of the quadratic function. However, in general, when we try to find the maximum or minimum of a quadratic function, we don't need to sketch the graph. Next, let me show you some examples. Find the maximum or minimum for each of the following quadratic functions. Here, let me show you how to find the maximum and minimum without sketching the graph. First example, f of x equal to x squared minus 4x minus 7. How can we find the maximum or minimum without sketching the graph? First of all, we need to tell that the function has a maximum or minimum. Here we know that a is 1, b is -4, c is -7. For this quadratic function, a is 1, b is -4, c is -7. We know that a is 1, which is greater than 0. If a is greater than 0, the graph is open upward. If the graph is open upward, we know it has a minimum. If the graph is open upward, we know this function has a minimum. And we know that the minimum located at a vertex. The minimum located at a vertex. Vertex usually locate an axis of symmetry. Vertex locate an axis of symmetry. So we can find the axis of symmetry first. The formula for axis of symmetry is -b over 2a. S equal to -b over 2a. Here b is -4 over 2 times a. Double negative is positive. We get 2. So the minimum occurs when s is 2. But for maximum or minimum, we need to find the y-coordinate of the vertex. For maximum or minimum, we need to find the y-coordinate of the vertex. So we plug in x, find the y-coordinate. Y-coordinate here is f of 2. So we plug in 2 for x, find the y-coordinate. Here we get 2 squared minus 4 times 2 minus 7. 2 squared is 4. 4 times 2 is a. 4 minus a is -4. -4 minus 7 is -11. So this is the minimum of function f. This is the minimum of function f. That's how we find maximum or minimum of a quadratic function. Next example. F of x equal to -x squared plus 6x plus 1. For this quadratic function, a is -1, b is 6, c is 1. Here, a is -1 is less than 0. If a is less than 0, the parabola is open downward. If it's open downward, it looks like this. It has a maximum. If the parabola is open downward, it has a maximum and a vertex. And we know that the vertex located at an axis of symmetric. Formula for axis of symmetry is -b over 2a. So plugging a and b, we get -6 over 2 times -1. On the bottom here, 2 times -1 is -2. 6 divided by -2 is +3. That means the maximum occurs when s equal to 3. And For maximum or minimum, we need to use the y-coordinate. For maximum or minimum, we need to use the y-coordinate. So plug in 3 into the function f, find the y-coordinate. Plug in 3 for x, find the y-coordinate. We get -3 squared plus 6 times 3 plus 1. 3 squared is 9. 6 times 3 is 18. -9 plus 18 is 9. 9 plus 1 is 10. That means the maximum here, f has a maximum. The maximum of function f is 10. The maximum of function f is 10. Next example, f of x equal to 2x squared plus ax plus 3. Try to find the maximum or minimum of this quadratic function. First of all, for this quadratic function, a is 2, b is a, c is 3. Since a is greater than 0, we know that the parabola is open upward. If the parabola is open upward, it has a minimum. If the parabola is open upward, it has a minimum and a vertex. And we know that the vertex located at the axis of symmetric. The formula for the axis of symmetric is -b over 2a. Plug in. b is a is 2. We get -a over 2 times 2 is 4. -a over 4 is -2. So we know that the minimum occurs when s is -2. And for the maximum or minimum, we need to use the y-coordinate. For the maximum or minimum, we always use the y-coordinate. So for the y-coordinate, plug in -2 for x. Y equal to f of -2. We get 2 times -2 squared plus a times -2 plus 3. -2 squared is 4. Two times 4 is 8. 8 times -2 is -16 plus 3. A minus 16 is -a. -a plus 3 is -5. So that's the y-coordinate and the vertex, which is the minimum. So minimum of f sub min means minimum of function f equal to -5. That's the answer. That's the minimum of this function. Next example, f of x equal to -2x squared plus 12x minus 5. Find the maximum or minimum of this quadratic function. So first step, write down a, b, c. Here a is -2, b is 12, c is -5. Write down a, b, c. Since a is less than 0, since a is less than 0 means it's negative. If a is less than 0, the parabola is open downward. If the parabola is open downward, it has a maximum. If the parabola is open downward, it has a maximum and a vertex. If the parabola is open downward, it has a maximum and a vertex. And the formula for the vertex located at axis of symmetric. Formula for the axis of symmetry is x equal to -b over 2a. Plug in numbers. b is 12. A is -2. So we get -12 over -4. -12 over -4 is positive 3. That means the maximum occurs when s equal to 3. The maximum occurs when s equal to 3. For maximum or minimum, always use the y-coordinate. So we plug in 3 for x, find the y-coordinate. Here y equal to f of 3, which is -2 times 3 squared plus 12 times 3 minus 5. Three squared is 9. 12 times 3 is 36. -2 times 9 is -18. Negative 18 plus 36 is positive 18. Positive 18 take away 5 is 13. So that's the maximum of function f. F max is 13. F sub max represents maximum of function f, which is 13. Next example. F of x is 3x squared minus x plus 2. Find the maximum or minimum of this quadratic function. First step, write down a, b, c. Here a is 3, b is -1, c is 2. Since a is greater than 0, the parabola is open upward. If it's open upward, it has a minimum and a vertex. And we know that vertex always located at the axis of symmetric. Vertex always located at the axis of symmetric. Formula for axis of symmetric is -b over 2a. Here b is -1, a is 3. Double negative, -1 is +1. On the bottom, 2 times 3 is 6. So the minimum occurs when s equal to 1/6. But be very, very careful. For maximum or minimum, we're always looking for the y coordinate. For maximum or minimum, we're always looking for the y coordinate. So for the y coordinate, plugging x into function f, we get f of 1/6. Plugging 1/6 for each x. 1/6 squared is 1/36. 3 times 1/36 is 1/12. Next, for this fraction, find the common denominator. First of all, write number 2 as 2/1. For 12, 6, and 1, the least common multiple of the denominator is 12. So for number 6 here, I multiply top and the bottom by 2. For number 1 on the bottom, I multiply top and the bottom by 12. Which turned out 1/12 minus 2/12 plus 24/12. Altogether, 1 minus 2 is -1. -1 plus 24 is -23. It's +23. So the y coordinate is 23/12. This is the minimum of function f. Next, f of x is 5x squared minus 3x minus 6. Find the maximum or minimum of this function f. So first step, write down a, b, c. Here a is 5, b is -3, c is -6. Since a is greater than 0, the parabola is open upward. Since a is greater than 0, the parabola is open upward. If the parabola is open upward, we can see that it has a minimum and a vertex. And the vertex always located at the axis of symmetric. And the formula for the axis of symmetric is s equal to -b over 2a. So plugging a and b. Here b is -3, a is 5. Here double negative is positive. We get 3/10. That means the minimum occurs when s equal to 3/10. But for the maximum or minimum value of a function, we need to use the y coordinate. For the maximum or minimum value of a function, always use the y coordinate. For the y coordinate, plugging x into the function, we get f of 3/10, which is 5 times 3/10 squared minus 3 times 3/10 minus 6. Here, 3/10 squared is 9/100. 3 times 3 over 10 is 9 over 10. 5 times 9 over 100 is 9 over 20. Minus 9 over 10 minus 6. Here 6 can be rewritten as 6 over 1. Next, find the least common multiple of the denominator. For 20, 10, and 1, the least common multiple is 20. In order to make 10 to be 20, I multiply top and bottom by 2. In order to make 1 to be 20, I multiply top and bottom by 20. So I get 9 over 20 minus 18 over 20 minus 120 over 20. Here, 9 minus 18 is negative 9. Negative 9 minus 120 is negative 129. And the y-coordinate here is negative 129 over 20. That means the minimum of the function is negative 129 over 20. So that's how we find maximum or minimum of a quadratic function. Next, let's look at a word problem. A manufacturer finds that the revenue generated by selling X units of a certain commodity is given by the function R of X equal to 100 minus 0.8x squared plus 20x, where the revenue is measured in dollars. What's the maximum revenue? And how many units should be manufactured to obtain the maximum? So here we try to find the maximum revenue. R of X represents the revenue. We try to find the maximum of the revenue. First of all, let's write the function in order. That means the term with higher power comes first. First step, write the function in descending order. Descending order means the term with higher power comes first. So first step, write the function in descending order. Next, try to recognize A, B, and C. Here A is negative 0.8, B is 20, C is 100. We try to find the maximum of the revenue. Here we know that A is less than 0. If A is less than 0, the parabola is open downward. If the parabola is open downward, it has a maximum and a vertex. And we know that the vertex located in the axis of symmetric. The formula for the axis of symmetric is negative b over 2a. Here b is 20, a is negative 0.8. We get negative 20 over 2 times negative 0.8 is negative 1.6. Negative 20 divided by negative 1.6. Here I can first of all double net become positive. Next, to make whole number here, I can multiply top and bottom by 10. Make 200 over 16. I can multiply top and bottom by 10. Make 200 over 16. Then for 200 over 16, I can divide top and bottom by 8. I get 25 over 2. That's x. That's the axis of symmetric. That means when s equal to 25 over 2, we have a maximum revenue. When s equal to 25 over 2, we have a maximum revenue. Next, for the maximum revenue, we need to plug in x to find the revenue, to find the maximum revenue, to find the y coordinate. So we have r of 25 over 2. If I plug in, I have negative 0.8 times 25 over 2 squared plus 20 times 25 over 2 plus 100. 0.8 can be written as 4 over 5. 0.8 is the same as a over 10. A over 10 can be reduced as 4 over 5. So 0.8 is 4 over 5. 25 over 2 squared. 25 squared is 625. 2 squared is 4. Next I can write 20 as 20 over 1 times 25 over 2 plus 100. Here I can cancel 4. 625 divided by 5 is 125. Here, 20 and 2 I can divide top and bottom by 2. I get 1 here and 10 here. 10 times 250, 10 times 25 is 250. Plus 100. Negative 125 plus 250 is 125. 125 plus 100 is 225. That's the maximum revenue. This is the maximum revenue. It occurs when s equal to 25 over 2. Next example, a farmer has 1,200 feet of fencing, and he wants to fence off a rectangular field for his horse. Find the dimension of the rectangle, then maximize the area. So a farmer wants to fence off a rectangular field. The longer side is called length. Shorter side is called width. Then he has a total of 1,200 feet of fencing, which means the total length of the fence is 1,200, which means twice the width plus twice the length is 1,200. We try to find the dimension of the rectangle, then maximize the area. We try to find the dimension of the rectangle, then maximize the area. We know that the area of a rectangle is length times width. The area of a rectangle is length times width. In this equation here, I can solve this equation for one of the letters. Either solve the equation for length or the width. Here, let me solve the equation for the length. If I try to solve for length, I can subtract 2w from both sides. If I try to solve an equation for length, I can subtract 2w from both sides. I get 2L equal to 1,200 minus 2W. Next, I can divide both sides by 2. I get length equal to 600 minus W. So length is 600 minus W. So the area of the rectangular field is 600 minus W times W. I replace L with 600 minus W. Next, I can distribute W. I get 600W minus W squared. Next, run the equation in order, in descending order, means the term with a higher power comes first. I get negative W squared plus 600W. Here, A is negative 1, B is 600. Since A is less than 0, the curve is open downward. When it's open downward, it has a maximum. When A is negative, the parabola is open downward. When the parabola is open downward, it has a maximum. Maximum occurs in the axis of symmetric. The formula for axis of symmetry is S equal to negative B over 2A. Here, our W represents X. In this function, W represents X. So we have W equal to negative B over 2A. Plugging A and B, we get negative 600 over 2 times A. A is negative 1. We get negative 600 over negative 2, which is 300. So the width, the maximum occurs when the width is 300. When the width is 300, the length equal to 600 minus width, which is 600 minus 300, which is also 300. So when the length and the width are both 300s, we have the maximum area. So when the length and the width of a rectangular field are both 300 feet. The area is a maximum.